1 1 0 0 1 0 1 1 1 0 1. Oh, excellent. I was so afraid we had to go to 4 digits. Okay. All right, let's get started. Hi, my name is Adrian, and I'm an engineering manager in Apple's Developer Tools Group. We are not a research organization per se, but I know from my own experience that our work is fundamentally interesting for somebody with a programming language research background. And because of the sheer scale of it, our work has a very direct impact on how people develop software. So our group provides the developer tools used by Apple to build all of its software. A lot of our work is done as open source. I'm sure you're familiar with some of the technologies that originated in our group, like the Clang compiler, the Swift programming language, or the LDB debugger. Using our tools, the entire Apple software stack is built and deployed to more than 2 billion devices. We also ship our developer tools to over 40 million registered developers who use them to write software for Apple platforms. A core value that's guiding our decisions is the user experience. And yes, that extends even to low-level developer tools. After all, developers are users too. We do deep technical work to ensure that tools are powerful and intuitive to use. What does it look like in practice? So let's take debugging as an example. Debugging is really important. Developers typically spend more time debugging existing code than writing new code. So developers have come to expect that they can step through their code in the debugger. When stepping through code, the stack will hold local variables and a return address. By unwinding the stack, the debugger can produce a backtrace. Developers have built an intuition that the backtrace explains how the program got here. Recently, we developed Swift concurrency to make it easy to write safe and correct multi-threaded code. We extended the Swift language with actors, async, and await keywords. So what happens if these were asynchronous APIs? If we annotate the function calls with await, the execution model and the compilation pipeline fundamentally changes. The compiler will break all functions apart at the await boundaries. Every new funclet either ends in a tail call or a task switch. Function parameters are packed into a heap object called the async context, and if we ask a debugger to produce a backtrace here, it will unwind the call stack and tell us that this function was dispatched on a new thread by the Swift concurrency runtime. That is technically correct, but completely useless. Under the hood, there's a lot of things are going on. The language design hides all this complexity, but if the tooling doesn't match, the metaphor breaks down. We don't want implementation details to seep through just because things are complicated underneath. We can use deep insights to present the world at an abstraction level that's meaningful for users. The async context pointer points to a heap data structure that holds a continuation pointer. It tells the runtime which funclet to dispatch to next. It also contains pointers to function arguments and local variables that need to be preserved across funclets, and each continuation has a pointer to its continuation. Now, the programmer's mental model was that the backtrace should tell them where the execution came from. But if you think about how it's generated by following the return addresses on the stack, it's really telling us where execution is going to next. Aha, but aren't async continuations also pointing to where the execution goes next? So, a smart debugger can follow the continuation chain to produce what we call a virtual backtrace, to turn this into this. And that's exactly what we do in LDB to produce a backtrace that matches the abstraction level of the programming language and the intuition of the developer. There's also a fascinating story about how we can make variables appear in these virtual frames that have not even been executed yet. If you're curious, there's a talk on YouTube from the last LVM dev meeting where I'm going into more detail about this. But this is all to say, a great user experience happens when we apply our deep understanding of the technology to present a complex world at just the right abstraction level. If this sparked your interest, we have full-time positions in the compilers, tools, and security analysis space in many global locations. And new ones are often added. Much of our work is done with the open source community, and you'll have an opportunity to build technology that has an impact on millions of software developers. Thank you.
So next up we have Zoe from Ethereum Foundation. Who's going to talk about the work that they do at Ethereum as well as some open positions that they have.
Hi everyone. No, that's not my. Yes, this is my slides. Okay. So hi everyone. I'm Zoe Paraskevopoulou. I work as a research engineer at the formal verification group of Ethereum Foundation, and our goal is to build languages and tooling in order to apply formal verification techniques on the Ethereum ecosystem. We are a group of 5 people. This is who we are, and we are all interested in languages and formal verification. And I will speak a little bit about the 2 main tools that we are developing these days, and then also about our open positions and how it is to working with the group. So the first tool is ATVM. It's a symbolic execution engine written in Haskell for EVM bytecode. We have a paper about it that is going to appear at CAV this coming July. And the idea is that we take EVM bytecode that may come from any language that compiles to EVM, like Solidity, or it can even be handwritten, and then we do symbolic execution to obtain all possible reachable states, and then using this information, we encode logical formula in order to encode the post conditions that we want to prove about the programs, and then we ask the SMT solver, and if we are lucky, we will either prove the property that we are interested in, or we will get a counterexample. If we are unlucky, the SMT solver will just time out. The second tool, which is still a work in progress, is ACT, which is a high-level specification language for smart contracts. And we can write a high-level summary of what the smart contract is supposed to be doing, and then we can use ATVM to prove that this high-level specification is equivalent with some EVM bytecode. And then we can use the specification to prove various properties by using different formal verification backends and encoding properties of the specification or the specification itself, either in a proof assistant, in Coke in particular. We encode the contract as a state transition system, and then we can prove arbitrary theorems about all possible reachable states. And we can also use SMT solvers to verify invariants and post conditions. And now, from our team, Sophie is working on having a TickMate backend for ACT, which lets us prove game theoretic properties and do some security reasoning. So if these all sound interesting to you, we are interested in growing our team. We are particularly interested in people who are knowledgeable in automated reasoning tools, or in proof assistance, or in functional programming, or in the blockchain. And any subset of these skills is valuable to us. We are remote-based, but we have very cool offices in Berlin, which we are visiting often. And we would also consider internships for the right candidates. So if any of these sound interesting to you, this is great. You can email me or come talk to me during PLDI, and I'll be happy to discuss more.
Okay, so next up we have presentations from faculty members. From now onwards, the talks will be around 2 minutes. I will be making announcements for the next speaker, so please show up when I announce your name. So because it's a sprinted version, try to be within the time. There would be enough time after this session where students can interact with faculty members as well as other people. So please also stay around until the end so that people can find you. So next up we have Anita, who's going to talk about positions.
Yeah, I just want to have like a shameless plug that I'm actually looking for one fully funded PhD student. If you're interested to work in programming languages plus security, interested in developing secure by construction frameworks that are legally compliant, or like you want to use WebAssembly, yeah, please come and talk to me. My preferred starting date is fall 2024, and then here is my email address. Please find me.
Hello, everybody. I'm Guido Salvaneschi. I'm a professor at the University of St. Gallen. That's a beautiful place in East Switzerland. We work on language design and verification, mostly for distributed systems. We have a paper on verifying algebraic laws on Friday afternoon. I'll be here until Friday. Come and talk to me if you're interested. Other topics are infrastructure as code, mixed consistency, CRDTs. Just come and talk if you are interested.
Do we have Fritz here?
Yes, so my name is Fritz, and I'm here on behalf of University of Copenhagen. That's the PLTC Programming Languages and Theory of Computation section. So what we work with in the section is functional high-performance programming, language-based system security, in general also functional programming, so a lot of programming languages, implementation, domain-specific languages, also on clarity of contracts and DLT, hybrid quantum classical computing and programming. We're starting in collaboration with a number of others. Deep probabilistic programming, so we're a third of the 4 in the third sections we have in our 8-section department that does machine learning. Anyway, so, we also work with language-based computability and complexity. That's the theory part. So this is, so what we have right now, we have a number of positions. So, if you're looking at you, maybe someone's looking at very starting, or maybe just a mixed faculty position. We're looking at all levels, also assistant professorships, in systems and software engineering, and PL, language-based security, language approaches are very well welcome. We have a long-standing history of working in programming languages. Neil Jones, for example, got a CPLAN Achievement Award, and so we worked on we're still continuing basically in the domain of semantics-based programming languages and applications in various domains, now including some of the topics you can see up here. Also, assistant professorship in computer science, you could say, which is entirely open. And again, please, make sure that we don't just only get machine learning applicants. So. And we have multiple postdoc and PhD fellowships in functional hybrid quantum classical programming. What does that mean? It means that, we're still waiting for, how it is, like subject to approval. But it's looking for, a combination of both quantum computing and classical high performance computing. It's driven by the recognition that most applications will be massively parallel classical and have core problems that are very hard to compute because they basically compute quantum effects. So this is at all levels, from very high level calculi to low level coding on machines, and also for quantum machines once they become available, by partners in this project, like NVIDIA and IBM. So PLTC, look at that website. I hope these slides will be made available. Yep. Right? And faculty positions are there, and the contacts are there. Thanks.
All right. Hello, everybody. My name is Eric Bodden, and I'm professor for secure software engineering at Paderborn University and Fraunhofer IM. And today I want to talk about a new exciting project that we have, in which altogether I can hire 6 PhD students and 2 postdocs actually. So for the last years I've been very heavily working on static analysis, and typical scenario that you have in this picture is what you see here. So this is Lisa, and Lisa is trying to use a static analysis tool in order to evaluate some software for security. But she's not very happy because the tool typically gives a bad signal, so it has lots of false warnings, false positives, it's slow, and it uses a lot of memory. And yeah, we have clever people, right? So, and larger companies, they have clever people too, and they then try to tamper around with the analysis configuration and sometimes even play around with the analysis implementation, try to speed it up. But this really takes PhD level experts to do this kind of work, right? And it doesn't scale very well. And what this project is now about, so that's an ERC Advanced Grant project, there we really try to fully automate this. So the project is called Self-Optimizing Static Analysis. And the idea is really that we want to build some kind of virtual machine. So the idea is here that we no longer program static analysis, we actually define them in some domain-specific declarative language. And then there's this magical virtual machine which under the hood automatically finds out the best analysis strategy, the best data structures, and so on, in order to give you really the best possible analysis implementation for the analysis problem and for the software that you seek to analyze. And that will require quite a few people to build, and I need people with a lot of different areas of expertise. You can see it here, static analysis, but also profiling, compilers, programming languages, a little bit of security. So PLDI should be a great place to find these kinds of people. If you're interested, please come talk to me. So we've fully funded PhD positions and postdoc positions for several years. And if you go to this website, you can also learn more about the project. There's actually also my proposal on there, which you can read if you like. Gives you a lot of detail on this. And I'm here until Thursday night, so very happy to talk to you. Thank you.
So, hi everybody, I'm Pietro Ferrara from University of Venice. So, first of all, who I am, but in particular who we are as a research group. So we have a research group, it's called on software and system verification. It's composed by several professors, okay? And all the root is in the first research interest you can see. Static analysis by abstract interpretation. Myself, I'm an expert in this field. I did my PhD thesis in the old times with Radia Couzeau, and that's where everything started. Starting from this, we applied static analysis in many different fields. So the latest one that we tackled is blockchain, and in particular smart contracts. We have a bunch of projects going on software engineering, on functional and non-functional requirements, and on cybersecurity of robotic systems, not only using static analysis, of course. Let's say the group grew quite a lot in the last few years. So essentially, we started with 3-4 people, and in 5 years, we scaled up to almost 20 people. So we expanded all our research interests. And we're interested in people in all these different fields, and even if you have something else in mind that might deal with security, application security, reliability of software, we are interested of hearing your things. In the meanwhile, we started a bunch of projects. One is the Lisa project. It's not Eric's Lisa that troubles with static analysis, but it's an engine for static analysis. We did a tutorial this morning with Luca Negrini. We have a spin-off working mostly on software architectures, and we're organizing some, let's say, networking activity, in particular the challenges of the software verification symposium in Venice. What we offer, of course, we offer Venice, well, not really, okay? Our campus, it's a very modern campus, it's nice, but it's in the main line. So, okay, it's just 10 minutes by public transport from Venice, but of course, you know, we offer Italian food and drinks. So it's, I think, a very good selling point. I cannot say a competitive salary as Eric, but okay, that's what we can say. We offer a nice environment. Here there are 2 of our PhD students attending PLMW, so you can talk with them to understand what we are doing. And we are looking for people at different levels. So, you know, internships. So we got a bunch of internships like the Erasmus+, but even if you are a PhD student somewhere else and you want to spend a period abroad, we are open to this. We have PhDs. The PhDs in Italy have yearly calls. So one just passed. Maybe there are few openings soon, I'm not sure, soon meaning next week or the week after, but there is a regular cycle that usually where the course has deadline in May. We can have pre- and postdocs scholarships, so if you are after the master but before the PhD or after the PhD, we have some budget available for this. And then also from time to time as a department, we have openings for tenure track positions, but of course these are not in charge of our laboratory, but to all the computer science department. Anyway, that's my email address. I will be around here until Friday lunchtime, so feel free to stop me and we can chat more about all this. Thank you.
Good afternoon, everyone. My name is Ilya Sergey. I'm an associate professor at the National University of Singapore. So since you're here at PLDI, I presume you all like to look at some systems code or at some proofs. I got both for you. What does this code do on the left? Well, you can probably deduce from the name it does. Does it do so correctly? Not sure. But I have the proof that it does so correctly. The question is, did I write that proof? Hell no. Did I write that code? Also no. This is what I wrote. So this specification says, take the list, produce the copy of the list, and the rest has been done automatically. So the code has been generated from this, the specification has been generated from this, and the rest has been generated by the tool called Suslick that we have developed with my students and my collaborator Nadia from UCSD. You can read the paper. This is an example of the stuff that we do in my lab on verified systems engineering. We look at the system stuff, and we look at the formal methods, and we make sure that we can bring them together with the power of types, logics, and program synthesis. If you enjoy this stuff, we have more of that. Furthermore, if you are, like me, like understanding and get to the bottom of complex systems, concurrency, distribution, compilers, like thinking about logics, type systems, really, really enjoy hacking proofs in Coq/Rock, although now we are mostly using Lin, and would like to come to conferences like PLDI relatively often and even better present papers here, well, then you know what to do. So like here. As a bonuses, you don't have to worry about PhD scholarship for 5 years. We have fully funded positions. I'm also looking for interns and postdocs, and I'm happy to chat with anyone who is interested. As an added bonus, we're in Singapore, the world, one of the most diverse, and probably by far from this size of cities, the safest city. That's what Singapore looks like. This is also Singapore, and this is Singapore. We have quite a lot of funding for travel. So despite Singapore being far east in Asia, I doubt that many of you will point it on the map, but it's there, it's below China. You get to travel around the world and go to nice conferences. So this is most of my team at PLDI'24. Oh, and yeah, so this is my mail. This is a durian, it's delicious. And we've got them too, all the year long. Lastly, it's not just me. So you always have a bunch of people to collaborate with. So shout out to my colleagues, Umang Manuel, Abik and Pratik. Umang is here, so thanks to him for running this workshop. That's fantastic work on data res detection. You should talk to him too. So I'm here until Friday night, and so are most of the people from National University of Singapore. Look at the badges, and happy to talk about it. Thank you.
Okay, so hi everyone, I'm Rodrigo Tony. I'm a postdoc in the systems group, standing in for Patrick Yogster, which is our group lead. And Patrick sent me here to basically ask you a question. So, do you want to conduct research, cutting-edge research motivated from and validated in a real-world context as part of a highly competitive team and project at a renowned university in a beautiful city and with very competitive remuneration? Then consider joining our group, the systems group at USI Lugana. So the focus of our group is research on distributed systems combined with programming languages and formal methods. Here you have like a list of some of our projects. Most of them have a flavor of programming languages one way or another. You can find on the website a full description of all our projects. We have both past and ongoing collaborations with many industrial partners such as Amazon, Google, and Meta. And at the moment we have open positions for prospective PhD students as well as interns. We regularly take interns in our group. And that gives you the possibility to live and work in the Mediterranean part of Switzerland. Here I show you a lovely picture. So here is an outline of our group and what we do. So Professor Yogster, he'll be here from Wednesday to Friday if you want to chat with him. He's very easy to approach on coffee breaks, very friendly, but of course you can also reach out by email, and below each of us you can see roughly what we do. On Wednesday morning, Anita is going to give our latest results, a talk on our latest results on how to algebraically specify and reason about quantum networks, their behavior. If that sounds interesting, please attend the talk. And of course, I'll be around, and many of our members of our team are also attending PLDI, so feel free to approach us at coffee breaks. So that's it, thank you.
Do we have Olivier here?
All right. Hi, I'm Olivier. I'm a research engineer at Galois. So Galois is a US-based research lab that specializes in trustworthy computing. We do work in different domains, including software correctness, cryptography, machine learning, and rigorous digital engineering. And our clients include DARPA, NASA, the Office for Naval Research, and we also have some commercial clients like Amazon. As a research engineer at Galois, you really have one foot in academia and one foot in industry. Most of our project involves extending techniques from the academic literature and implementing prototypes that solve some of our clients' problem. I also get to work on a ton of different interesting projects in a variety of topics. For example, my background was in verified compilation, but since joining, I worked in network verification, program synthesis, and a few projects on language-based security. One thing I appreciate there is the flexibility to work on the projects that you find interesting, but also on the location you work for, as long as it's within the US, and flexibility on your schedule as well. So we have 2 papers at PLDI this year. You can go see the talk. They're both on Wednesday. One is on DSL for parsers, and the other one is on network verification. So talk to Yavor or myself if you have questions about Galois or about the papers themselves. And we are hiring. At the moment, we're looking in particular for research engineers with a background in verification, differential privacy, and for principal scientists, but we should have opening for internships later this year. Thank you.
So, hello everyone, I'm Alessandro, and I'm research and development engineer / scientist at Planting Space. And I'm here today to present at the eGraphs workshop, another project made for eGraphs in Julia. And we're looking for compiler hackers. We're looking for multidisciplinary skill sets. So what are we building? We're building a pretty crazy AI system. And what's the issue with current machine learning is explainability, of course. Everyone knows about it. There's lots of work on it. So we're doing lots of research-based work in industry, working with cutting-edge research. And we're basing everything on category theory, Bayesian statistics, using lots of learning, and also applying cognitive science. And this work, surprisingly, involves skills from the programming language world. And how do we get explainable AI from programming language hacking? Many problems involve the Julia programming language, which is a meta language, and so we do a lot of meta programming around. And category theory and functional programming, go hand in hand. And many problems are based, for example, on similar data structures and algorithms that we have in compilers. So if you want to see some examples, you can check out the link there for the example problems. There is a bunch. And it's an interesting position. We work on many different, with lots of cutting-edge research from all different fields. And we're fully remote. We are pretty much hiring around in Europe, and we have lots of team retreats, so we meet regularly in super cool locations around Europe. And if you like Lisp, I guess lots of people here like Lisp as a language, I think you'll like Julia as well and the stuff that we're doing. So if you're interested, I'll be here pretty much the whole week, so you can catch me around for a coffee break, or send me an email at alessandro@plantingspace, and here's the link for looking at the current openings. And the relevant one is obviously the software engineer position. And thank you everyone.
So hello everyone, I'm Conrad. I'm an assistant professor at NTU Singapore. And I work on WebAssembly. I am one of the co-chairs of the standards body on the industrial side. And then on the research side, I work on thinking about concurrency features for WebAssembly. I've done verified implementations of WebAssembly in specifications. We found problems and fixed them in the type system, for example. And we're doing some work on specification tooling and automation, including a PLDI paper, which you will see on Thursday. So I now have in NTU quite a large grant for setting up a new lab based on my interests in WebAssembly and PL. And as part of this, I'm looking to recruit PhD students and postdocs at all levels. If you are interested in WebAssembly and excited about the chance to do something in Singapore, come and find me. There are some internships available as well. And it's no exaggeration to say that your contributions to WebAssembly will be running in billions of devices worldwide. So if that excites you, come and talk to me. I'm not the only person doing PL in NTU. We have a couple of new colleagues as part of the expansion of our faculty. So Luke Ong recently moved from Oxford. He works on probabilistic programs and game semantics. We have Liu Yang, who often works at the intersection of PL and cybersecurity and software engineering. And incoming this year, we have Yong Kiam, who worked on the CakeML project as quite a senior contributor. And the final thing I'll end off with is NTU is rapidly expanding. We're a very young university, so apologies for the ranking, but we need people to know how exciting we are. We used to be under the College of Engineering as a Department of Computer Science. We are now a separate College of Computer Science. So as part of this, we're looking to hire a lot of new faculty. If you feel you're ready to take that step, please consider us and talk to me if you're interested. Thanks for your time.
Hello, I'm Ruslan Nikolaev from Penn State in the United States, and I'm an assistant professor and just have a few words about possible PhD positions at Penn State. First of all, the CSE department at Penn State is always looking for strong PhD and master students in many areas, and you can visit the website for the admission information in fall and spring. So now, if you are looking specifically for low-level OS programming, or you want to do some concurrency stuff like log-free algorithms, weight-free algorithms, want to target like really kind of ambitious goals to like publish in top-tier conferences, PLDI, ASPLOS, SOSP, OSDI, PPOP, POTC, you name it, right? So and you know, join my research group. I'm really looking for good PhD students. We've funded for at least 4 years. And, you know, so I'm looking forward to do cutting-edge research in the areas of operating systems, concurrency, security, and security in the sense of how it relates to operating systems or programming languages, and other related areas. So also, master students, in some cases, can also be considered. So if you're a master student, you want to be a master student, also can get in touch with me. So just a little bit about myself and my research group. So as I said, I'm an assistant professor with Penn State, fairly recent. So currently I'm advising 3 PhD students already. I'm advising some masters and undergraduate students. Previously, I was a research faculty at Virginia Tech, and you know there were already some students who graduated, like PhD and master students, and Professor Binoy Ravindran from Virginia Tech, from System Software Research Group, is also recruiting students in verification and systems. So you can get in touch with him as well. So I just wanted to kind of spread the word. So coming back to my kind of experience, I also worked as a senior software engineer in Pure Storage and software engineer in Microsoft, so I have both industry and academic background, so that can help in our research work. So please visit my homepage or email to me. I'm also going to be here till the end of the week. I'm going to have my presentation on Friday at PLDI, so please feel free to get in touch and we can have an in-person conversation. Thank you.
So my name is Lázaro. I'm a founding engineer at Guitar. So what the hell is Guitar? First of all, it's a software startup. It was created last year. It's actually created by a lot of the people who built developer platform at Uber. So basically in 2017, we were starting to build a lot of the tooling that larger companies at the time had, like Meta or Google, and this is static and dynamic analysis, this is production profiling, this is managed development environments, and this is automated code refactoring. And as we were building this, we realized, well, this is stuff that a lot of companies will need sooner or later, and not all of them can afford to build, so we created a company to sell that. And we're starting with automated code refactoring and automated code cleanup for 2 reasons. Developers spend around 30% of their time in code maintenance tasks, and we have a very good foundation from this research work that we did at Uber that is going to be presented at the PLDI main conference on polyglot code transformation. So as I said, the team is ex-Uber, but also has very deep experience within industry. It's around 50% PL PhDs, and the rest is also like very good product and integration engineers. We have offices both in the Bay Area and in Amsterdam, and we're looking mostly to hire 2025 PhD interns, but we're happy to talk with anybody who's interested in what the hell we do and what we're about. Thank you very much.
Hi, so I'm Klaus von Gleisenthal. I'm assistant professor at VU Amsterdam. And what I work on is sort of at the intersection of programming languages, systems, and security. And so the thing I've been most interested in recently is hardware security. And if you know one thing about hardware security is that it's absolutely broken. It leaks everywhere. It leaks through timing leaks, cache leaks. And now it also leaks through transient execution leaks. So that means even if you're never going to take a path in your regular program, the program, because it wants to be faster, the processor wants to be faster, so the processor can still execute that path and then leak your data, even though that should never happen. And so basically, people made that realization around 5 years ago, and since then, there have been a never-ending stream of new transient execution attacks. And so that really raises the question of how can we fix this, and how can we build better hardware that's actually provably secure, and that's what I'm working on. And we're using all the, the tools that you probably like since you're here, so types, proofs, and actually you can write your hardware in Haskell with a tool called Clash, and it combines down to Verilog, and you can actually use it to make an FPGA with all this stuff. All right, so if you're interested in that, why should you do it at VU Amsterdam? So VU Amsterdam has a very long systems tradition. So if you did an operating system course, then there's a good chance that you used the book by Andy Tannenbaum, who started the systems group in the department. And more recently, the systems work at Amsterdam is around hardware security and transient execution attacks. So that's the WUSEC group. So that's really sort of the ideal environment to do this sort of research. And now we also have a new PL group that's ambitious and that has 15-year-old teams like this one. And we have multiple open PhD positions funded by an ERC grant. So if you're interested, get in touch, talk to me. I'm here throughout the week. And of course, you can write me an email. And the last reason to come is, of course, Amsterdam, because it's amazing. So thanks.
Okay, hi, everyone. I'm Derek Dreyer. And it's my pleasure to say a few words about my institute, where I've been working for over 16 years now, called the Max Planck Institute for Software Systems. What are we? We're actually one of around 80 Max Planck Institutes spread throughout Germany, covering many different topics, and one of 4 institutes that, broadly speaking, cover computer science. Our institute is located in 2 cities, actually, in Kaiserslautern and Saarbrücken, which are both in the western part of Germany, not very far from each other. Let me start with a sort of high-level sales pitch about our institute, which is that I think in the area of programming languages and verification, we're really a world-class institution. We have many different faculty working in this area in the different aspects of these topics and the different subsets of those conferences that are listed there. We have 2 Milner Award winners and 2 recent dissertation award winners. There's a lot of exciting stuff going on. I actually mainly wanted to do 2 things here, which one was to advertise Andrea. Oh, can I not move the mouse? Oh, I can. Okay. Andrea. Who's a new faculty at our institute starting this fall. He works on verification tools for Rust programs, and he's definitely looking for new students and postdocs. So if you're interested, come talk to me. I can tell you about the kind of stuff he works on. The other one is just to tell you a little bit about my group. This is a picture of my group from a few months ago. We're a diverse bunch of people working on a diverse bunch of topics. There's actually, if you want to get sort of more hands-on understanding of what we're doing, I would say talk to Simon, who's over there on the left, and Leonard, who's over there standing next to me on the right of the picture. They're going to be here presenting their PLDI papers this week. And actually, there's several of our alumni of the group. Michael Zomler is here, Ralph Jung is here, Andreas Rosberg, who you may know as one of the lead designers of WebAssembly, was actually the first member I ever had in the group. Come talk to these people and they'll tell you what MPI is like. Let me just briefly say kind of stuff we do. So we study a range of different topics, but they're all sort of in the space of separation logic, type systems, semantics, and machine check proof. We do a lot of stuff in the Coq proof assistant. Probably the projects we're most well known for are Iris and Rustbelt, as you see at the top there. Iris is basically now a sort of the state-of-the-art tool for doing separation logic proofs machine checked in Coq. And Rustbelt is a project that was sort of the first project to develop formal foundations for the Rust programming language and prove soundness of the type system, and that was also done on top of Iris. There have been a number of projects that built on top of these things over the past several years. So Refined C was a project that Michael Zomler, my former student, did and presented at PLDI a couple of years ago. Quiver and Refined Rust are the 2 papers we have at PLDI this year, and Verus is the tool that Andrea Latuada has been building for verification of Rust programs, and I expect there's going to be more coordination, integration between all these tools going forward. So if you're interested in learning more about all this stuff, just come talk to me. I'm here all week long. Thanks.
Hi, everyone. I'm Taro Sekiyama, an associate professor at the National Institute of Informatics in Japan. So our project is to secure systems by collaborations between hardware, system software, and formal verifications. So the role of our hardware verification in this project is to provide some encryption and isolation primitives for protecting data and code over user applications. And the system software provides a flexible protection interface to the user applications. And the formal verifications aims to guarantee the data and code over user applications is actually protected using the primitives given by the system software. So we are working on the formal verification. So our team is looking for internship students and PhD students and postdoctoral researchers who are interested in formal verifications in software systems. So our target is a large and complex low-level software systems like OS, operating system, and hypervisor. So we are focusing on scalable, modular, automated security verifications for this project. So so now we are recruiting people interested in such topics. So please get in touch if you want to know more. Thanks.
Hi, everyone. My name is Alex Lev, and I'll be starting a new research group at Yale starting in fall 2025. So if you're thinking about applying to PhD programs this fall, please consider Yale if you're interested in joining a group that's going to be focusing on probabilistic and differentiable programming. If you haven't heard of probabilistic and differentiable programming before, the idea is that we're going to let users write down machine learning models, simulators, other sort of complex probability distributions as programs, and then automate all sorts of mathematical operations on those objects that the users wrote down using ideas from programming languages. One of the things that I've really enjoyed about working in this field is that you get to really work at the intersection of programming languages and machine learning. You get to draw on and extend lots of very cool techniques from programming languages, all the way from very theoretical stuff like denotational semantics to more applied compiler hacking or automated reasoning, and apply them in these settings that are really relevant to a lot of the conversations that are happening in computer science today around machine learning and AI. You also get to sort of study some of the same questions that machine learning PhD students work on, but from a sort of PL angle that's more interested in thinking deeply about the compositional structure of those computations. And that often surfaces really cool and beautiful math at the heart of these projects. So if you think that sounds fun, I'd love to hear from you. You can find my contact information there. Also, besides all of the cool sort of research reasons to work on this stuff, Yale is also an awesome place to spend a few years. It's currently the #2 highest stipend relative to cost of living, partly thanks to Yale's new grad student union. It has a rapidly growing computer science department. They've hired a bunch of new faculty in the past couple years. A really thriving art scene, quick train to New York City, and great other CS faculty and faculty across the school for interdisciplinary work. So thanks.
Actually, hello everyone. Actually, I'm the PhD student of Nuno Lopes. He is on his way to here, so let me introduce the slides. Yeah, that's you can look at these slides. And one thing that my advisor let me mention is our research is mainly focused on the compiler things that can we researching and developing that things that can deployed and used in the industry. And yeah, what the slides shows is what we previously did. And Nuno Lopes is author of the Alive2 translation validation tools, which is used for used by many LVM developers. Okay. The way the algorithm to search Nuno Lopes is you can find the guy that is tallest, and he's very tall. Yeah, and or just search his name in Google and find his email and drop him email. Okay, thanks.
All right, hello everyone. I'm excited to talk about our work in our research group in Berlin at Technical University. So my name is Michael Stoiber and I'm leading the compiler and programming language group there. Besides me, you can also talk to 4 other PhD students of our group who are here this week. Nicole and Serkan, which you might have met at PLMW, and Rudi, who presented today at the eGraph workshop, and Bastian will present at PLDI. So what do we do in Berlin, which is a very nice city and exciting international city to live in? So we do research in kind of 3 larger areas. So we do research in compiler construction. Particularly, we are interested in kind of domain-specific languages, particularly with a focus for specialized and parallel hardware devices. So kind of the more fancy the hardware gets, the more interesting it gets to design languages for it. And we are interested in kind of building compilers for these hardware. Ideally, we'd like to build them fairly quickly because this is currently a very costly process. So we have done research into thinking about how to simplify and automate compiler construction. And we have some work in kind of compiler-oriented, but also functional programming conferences in that area. And we have a theme where we look a lot into rewrite-based optimization. So we try to express compiler optimizations kind of formally so that we can automate the application, right? But we also want compiler engineers to still be kind of in control to decide what to optimize and how. And so we have done work around Elevate, which is a way to describe scheduling languages formally. So these are languages where you describe what optimizations to apply. And we are doing currently quite a bit of work on a topic called equality saturation, which is a kind of exciting theme. And then we do work in programming languages, particular for these specialized hardware devices, so stuff like GPUs and even weirder architectures. And we are going to, Bastian, one of my students, will present this week this language called Descent, which is a Rust-like GPU programming language. And for that, we will have like extended kind of formal rewrite rules, and we have an implementation and so on. So come to this talk if you want to on Wednesday at 5 p.m. And if you're interested in joining our group, contact me. I'm looking for PhD student postdocs in the next year. All right, thank you.
So the next set of slides is by Matthew Parkinson. Unfortunately, he could not make it. I'll just briefly talk about the work that his team does at Azure. The group mostly focuses on security and privacy and work on programming languages, systems, and cryptographic aspects of these. They're looking for interns as well as postdocs starting 2025. So please feel free to reach out by sending an email to Matthew Parkinson if this interests you. These slides will be shared, have been shared already. Next up, we have Sebastian.
Hi, I am Sébastien Bardin. I work in CEA, France, close to Paris. Basically, I am working on binary level security and program analysis, and we use programming language, formal methods, and for verification, bug hunting, synthesis, and so on. So my group is 10 people, mostly, so some junior researchers, some postdocs, and some PhD students. So basically what we try to do is to take all the nice techniques that have been designed for source level verification and try to see what happens when you want to use that at binary level. So we have looked at a large number of programs like reverse engineering of protected code like malware and so on. What happens when you want to do some verification but the adversary is able to observe side channels or microarchitectural attacks? What happens when he can inject faults like laser, rohammer, these kind of things? So basically any low-level security problem, we try to see how we can see it from the programming language and formal method perspective. How do we change the theory and how do we change the algorithm and the tooling? We have currently 6 open positions, either postdoc fully funded, either postdoc or PhD. So our current projects are about malware analysis, vulnerability analysis, and security evaluation and certification at binary level. So here I put some example of possible topic, but the list is not closed. So we have some work on considering attackers into programming language methods, microarchitectural attacks, side channel attacks, how to evaluate the dangerosity of a bugs. So let's say, for example, you have 1,000 open bugs. Which are the more important, and how do you define that? How can you compute that, and so on. Typical underlying techniques we use, symbolic execution a lot, SMT solving, combination of static and dynamic methods, abstract interpretation, formal synthesis, and so on. The positions are open now, so if you're interested, do not hesitate. I will be there until the end of PLDI, so you can also send me an email or look at our website. Thank you.
Hi, I'm Vikash Mansinka. I'm from the Massachusetts Institute of Technology, and I'm representing the Probabilistic Computing Project and the Quest for Intelligence, which is a new interdisciplinary lab spanning computer science, artificial intelligence, and the brain and cognitive sciences. So we're interested in understanding how intelligence arises and to what extent it can be interpreted as a kind of probabilistic computation. And to do that, we're doing a lot of very basic research in probabilistic programming systems, in foundational theory, some of which we'll hear about at PLDI this year, and in the deeper questions of integrating symbolic, probabilistic, and differentiable approaches to computation. We also build large-scale AI systems, some at our universities, some with partnered nonprofits, and then with industry partners in domains such as 3D scene perception, large-scale record linkage, and automated modeling of databases and multivariate data streams. So if you're interested in any parts of this interdisciplinary endeavor, from basic PPL research to programming systems engineering to AI research, please come talk to us. You can email me or Josh Tenenbaum, who co-advises many of my students. We're looking for staff scientists. We're looking for software engineers to help develop our GEN probabilistic programming language, which is seeing increasing use at other universities and industry. We're looking for PhD students and postdocs. We have a couple alums, Alex Lev and Faraz Saad. Alex you saw earlier, who's also recruiting, and Faraz may be recruiting, so I encourage you to go talk to them as well if you're interested in some of these themes. And if you are or know of postbacks who are looking to get into a top computer science PhD program, we also have some opportunities for students at that career stage. Thank you very much.
It's a very tough act to follow. Hi, everybody. I'm Aditya, and I am going to be starting as an assistant professor at the University of Wisconsin-Madison in Jan 2025. So I'm looking for students to join in fall 25. I've put up my website here and my Twitter handle. You can contact me using through either. I'll have my email ID updated on the website pretty soon. What we would be doing in the lab is study automated verification primarily as it relates to building verified systems. We have a particularly unique approach here in the way that we do, in that we look at these things from a very practical perspective of how your everyday systems programmer might be able to build verified systems. When we look at these things from a very foundational perspective, we look at both theory and practice, as well as the human factors associated with them. And as a consequence of that, you come across some very interesting problems in synthesis, and more recently, the application of learning techniques, especially learning of logical expressions or logic learning to these problems. Now, this is what I expect to be doing, but there is always the other factor, which is who you are and what you might bring to the lab. Unfortunately, that is not displaying on the screen, so let me just tell you anyway. Who you might be is somebody who is, passionate about the problem. The primary component of what I'm really looking for is energy. I do some of my best work with people who have their own agenda, and we explore some interesting topics together. You're passionate about the problem. You're annoyed about how hard it is, and you want to fix it at any cost, and you like having friends with similar attitudes, and that's the kind of person I'm looking for. And as to why the University of Wisconsin-Madison, it is already a fairly large department, many different perspectives. We have people in machine learning, people in HCI, people doing types and trustworthy AI, and most of it being just done by my colleague Aus, who will be speaking tomorrow. And more importantly, it's a very beautiful place to do some of your best work. It is an incredibly collaborative and supportive environment. There's a huge focus at the departmental level on your development as an individual, and all the faculty are essentially aligned with that kind of goal. So it's really a wonderful place to do your PhD. And last, I'm going to do a very quick shameless plug for my paper that I will be presenting on Thursday. I was informed very recently that it won the ACM Europe Best Paper Award. So if you want to be on that train, please come see the talk and join us. Thank you.
Okay, so this is the end of the presenters of the slides. The presenters are encouraged to stay back, and the students are encouraged to find people who you would like to work with. Anita, on to you.
Concluding remarks for today. I hope you have some fun today. Did you? Well, that's nice. But tomorrow is going to be relatively more formal and a packed program. I just have one announcement regarding tomorrow's program. So there's going to be mentoring lunch, as I probably said in the beginning. And if the faculty or like any seniors here are interested in being mentors, please let us know so that we can ensure that the tables get like at least 2 mentors. So please let us know. Tomorrow we'll be distributing the mentor badges so that you're easy to find. With that, yeah, thank you.